Hi everybody, welcome back. I'm going to break up two videos today. The first one we're going to just look at the concepts of what is happening with a coil inside of a DC circuit. And specifically we're going to look at current. So two of the properties of this coil, when we're going to build a coil, we're going to take some sort of material for the core. It could be iron, it could just be an air core. But something like iron will help us to understand it a little better. We're going to take a wire and wrap it around that core. So the two properties of this coil is the resistive property based on things like the wire that we picked, the material, the size of that wire, the length of the wire, and the temperature that is sitting in. The other property is the inductive property of that circuit based on the number of turns and the permeability, the area of the core and the length of the core. That's what the two properties of that coil are going to be. This inductive property causes an opposition to a change in current, meaning at the point of energization, rather than current reaching a maximum value, what it takes is a period of time for that current to reach a steady state or a maximum value. So we can look at that on a graph and see at the point of energization that rather than it reaching a maximum value, that it takes a period of time for it to reach that maximum value. And that is broken up into what we know as time constants. So each individual time constant is equal. So the first time constant is a rise of 63.2% of that maximum value of current. The second is another increase of 63.2% from that first time constant. And we break these down, and if we look at this waveform, we know that at the fifth time constant, that's where current would be at its steady state. The current that's going to flow in this circuit is going to be determined upon just a simple Ohm's law statement. The magnitude of the applied EMF and the opposition in that circuit. The amount of time that it's going to take to reach that steady state is determined by the inductance of that circuit and the opposition to current flow, the resistive component of that coil. That inductance is measured in henries, the resistance is an ohmic function, and our time is measured in seconds. The other way that we can look at this is through the log function, that if we look at that maximum value of current, and on our rise formula or our ascending curve, we can look at 1 minus e to the negative time constant to calculate what the magnitude of current is at each individual point in time. So this is just the first part of this that we're going to look at and understanding what is happening with time within this circuit. The next will be actually some calculations to see what's happening. Hope this has helped. See you next time.